Hi girls, let's start and continue our previous part. In the previous video, we discussed and we reviewed chapter 7, and you told me that you had some slides you couldn't see them. For that, I created for you this PowerPoint to show you everything that I was saying and writing on my whiteboard. Let's get started. So in this lesson, in the first 4 lessons, we discussed about the properties of exponent. So if we have the same base, we are going to add the powers. If we have a power raised to another power, we are going to multiply them. And here is example, if you have parentheses like this, and if you have two numbers multiplied and they raised all this number to power m, you can distribute them. And I was telling you when I was explaining in the class, if you have, for example, between them addition, you cannot distribute the power. Be careful on that, which is here some examples. You can review my PowerPoint and my video anytime you want. So if we have negative exponent, which is given in lesson 1, a to the power negative m, you will move this down and then raise it to a positive power. Here is example. Same thing if you have a 0 exponent. If you raised anything to 0 power, you will gonna get directly 1, which is here is example. Now quotient of powers, also if you have same base and the operation between them division, so you are going to subtract the powers, which is exactly the same as this one, exactly same. But what is the only difference between them? You can say, for example, I just want to show you from this one how I will move from this one into this one, which is exactly the same idea, but only by subtraction. So we had a to the power m over a to the power n. We can say that a to the power m, and by using this property, which is the negative exponent, since this down, I can move it up, and by doing multiplication between them times a to the power minus n. Now they are same base, but different powers. I'm going to add my powers. So a to the power m plus minus, it will be minus n. So that's what I had. So keep this in your mind. Just I want you to know that there is big relationship between them. Also, one more thing, this one and this property, which is distributing the power. If you have different bases, but these two bases raised to a specific power, you can distribute your power and do your calculation like this. Here is example. So that's the revision that I did yesterday, but the only difference I was writing. So that's, I think, more organized than writing, because it's very difficult to write by mouse. Also, I was telling you about the exponential function. So it should be on the form which is given in lesson 7.5. So all these, we discussed them in the first 4 lessons. We had some expressions, and we simplified them by using these properties. In lesson 5, we discussed about exponential function, which should be written like this form. Keep in your mind that a is the initial value in the problem that we have, while b, this is the common difference that I will usually have it. Common ratio, I mean, not common difference. So this is the common ratio. This b is the common ratio. So if this b, the one that raised to a power, if this b greater than 1, which is like this example, 2 to the power x, the exponential function should be graphed like this. While if you have negative and this number b is greater than 1 again, you are going to reflect your graph like this around the x-axis like this. While here, if you have the b is less than 1, I mean, it's a fraction like this. So you are going to say the direction will be for the exponential function like this. Now, if you have a number like this less than 1 and there is negative, that means you are going to reflect it again. You are going to reflect it over the x-axis. So this is the idea that we learned. What is useful from all this? Once I graph, I know how the graph will look like. So that's what the thing that will help me. In this lesson, we learned the geometric sequence, which is the last lesson 7-8. So this is just a quick revision about lesson 7-5 and 7-6. Here, in the last lesson, which is lesson 7-8, we had geometric sequence and how can we write it in explicit formula and recursive formula. And I reminded you that we learned before the arithmetic sequence. So the explicit formula, we have to focus only on this part, but I usually like to remind you things that we learned before so you can keep them in your mind. So the explicit formula for the geometric and what we learned, that's what we learned, which is this one, an equals to the 1, which is the first term, then times r to the power n minus 1. So this r is the common ratio, which is here. There is explanation that will help you. While the recursive formula, which is a1 represent the first term, you must write it, then an equal r times an minus 1, which is the previous term. You can just see that here written more explanation. So that's what we discussed. We found in some exercises I will show you now. And in the first slide here, I repeated for you just the part that I discussed with you. I'm not just discussing this part with you again, because you can see them in my previous video. These exercises, which is simplify expression, these are from lesson 7-1 until 7-1 until 7-4. By using all the properties that I discussed with you in the first slide. Also, we had evaluating in this part. Again, we are going to use the same property that we learned and the order of operation in this part. So I really encourage you to simplify first, then substitute. If you can do the opposite, you can substitute first, then simplify your expression and do your calculation. Do the way that you like, you will get the same result. Make sure that you try them alone and check the answer from my previous video. Also, we discussed this part. I just discussed with you this quick and fast. I don't know if you face difficulty with this one. As I told you, this kind of a question will be similar to the lesson 7-7. But I did not give you this lesson 7-7. But why I explain it? Because I know some students, they like to have more knowledge and more information and more practice, and you might see it in Pearson test. All right, so I'm not just doing it again. I'm not wasting the time doing same exercises that I did before. Just a quick review. Volume of a cube, I also did this one. Keep in your mind there is 5 here. This one I also did it, which is here supposed to be multiplication. Just a quick note about this one, because some students, they were telling me during the office hour that, Miss, we did not get the same result that given in the answer key. Yes, girls, it is not the same, but I believe that there is a mistake in the answer key, so you don't need to worry about it. The answer that I gave you during the session was the correct answer, because the idea is clear, because it's the distance equal, we have a famous rule, which is the distance equals the speed over time, which is related to physics. As I told you, something in my test, I'm not giving you anything depend on some concepts in physics. I will give you some question depend on math concepts, but keep in your mind, you might have this in Pearson, because Pearson including all the question that given in the same store. So you must practice it and you must increase your knowledge and connect between all the science subjects. So this one we substituted like this yesterday. We said we had the speed as a 3 times 10 to the power 5, but that was kilometer per second. But if you notice that they want for me to find the time 1 year, but how this is second and here 1 year? That means I need to convert this one or this one into to make them the same unit, because these represent time, both of them, but one from them in second, one from them in years. So how can I have this? I just need to know, I know that if I want to convert from big to small, I need to multiply. And that's what I taught you before. So just that's what I did. I felt like that was a little bit confusing. So that's why I repeat it. So 1 year, to convert 1 year into 2 seconds. 1 year, there is 24 days, 24 hours, sorry, per day. Now I will multiply this 1 year. I will write it instead of this one. I will write it 365 seconds. So that will be, let me erase the 1. So you know why I changed this one. So instead of 1, I'm going to write 365. So that is 365 times 24, which means there is 24 hours in a day. Then there is, in each hour, there is 60 minutes. In each minute, there is 60 seconds. So once you divide all these two quantity, you are going to get 9.5 something, 9.5 times 10 to the power -3. So now you got the result, and that's correct result. So that is the distance, that is kilometer. That is kilometer. Just, I'm looking for the distance, so that is kilometer. Now I will move to the next part. Also, I discussed with you this part, which is easy. Just you need to substitute this part, this r, which is the radius here, and this r, and this pi by 3.14, and do your calculation easily. Same thing with this one and this one. So the speed sound here again, it's just need discuss about speed and time, which is similar to the idea that I did here. So I'm not going to do it. Now we will start lesson 7.5. So the first part was about from lesson 7.1 until 7.4. Here is lesson 7.5. 7.5, in this lesson, we learned about the rational exponent. So rational exponent, as I told you, was kind of roots. Cubic root, second root, and so on. So when I want to find this, basically, I need to think about what is the number. When I multiply it by itself 2 times, I will get, because the degree here 2, when I will look at the number, when I multiply it by itself 2 times, I will get 64. Definitely, we are memorizing these because 64 is easy, which is 8. I know 8 times 8 will give me 64. All these numbers, girls, you already know them because these are easy and basic. But if we are using calculator, so let me use calculator with this one. There is 2 ways to find this one, by calculator, and there is another way to do it without calculator. So I will remind you all this way. First way, by calculator, I will put shift, and then I will put on I will press the bottom, that x to the power like this. But if I put shift, I will get this power, this thing. I will get the square root inside it, small square like this. Then I will enter the number that I have inside them. Then I will get the result. The other way, I know that this one, this number is how can I write it as a fraction? I know that this is a 3, 4, 3, all this to power 1/3. Right? I'm going to write the power here as 1, while here the power outside the 3, which is for the root, which is I know that this will be 1/3, 1 over the degree of the root. So I can again, I can press this x to the power to a specific power. Just to press, you will find it square here. You will put this number that you have here. Once you click on this bottom, also click on this box, you want to enter this fraction. You need to click the fraction bar that you have in your calculator like this. Then you will put here 1 and then here down a 3. The last way, which is doing it without calculator, as I told you, sometime if you are on some موهبة test or something like that, or let's say قدرات, you need to have them solving this kind of a question without calculator. I will look at the prime factorization. I mean, I want to rewrite this number into a powers. So I'm going to factor this one by using prime numbers. And I mentioned the meaning of a prime numbers, which is the numbers that I can divide them only by themselves and 1. So what is the best number here? If you think about 2, no, you cannot, because here this number started with a 3. If you started dividing by 3, so once you divide this by 3, so to save the time, just I will divide fast by 3. So that will give you, divided by 3, that will give you, so 3 also you cannot divide it by 3. So move to more than 3. Just try 5, you cannot 5 also. 6 is not a prime number. Try by 7. You need to try by 7. So 6, 4, 3 divided by 7, which will give you 49. Yes, so 7 is a prime number. When I divide this 3, 4, 3 divided by 7, I will get 49. Just to show you, if you are again in, for example, موهبة test or any test, just go make your division box 3, 3. So you, as I said, 2 impossible because that is odd number. If you say 3, you will add them. 3 plus 4, it's 10. Plus 3, it's 10. So 10 is not multiple of 3. That means you cannot divide it by 3. If you move to 4, 4, no, you cannot. 4 is not a prime number. 5, no. 5, you cannot divide any number like this. You can divide by 5 only if you have 5 here or 0. Then you will move to 6. 6 is not a prime number. 7, yes. So 7, once you start 7, so that is a 3, sorry. So the closest number is, what is the closest number? 5, when you multiply 5 by 35, which is wrong. That means it's 4. So 4 times 7, which is a 29. Subtract and do the rest of the calculation, and then you will see it 49. Then you will complete. That's so easy to find. 7 again, which is 7. 49 divided by 7, which is 7, because you memorized the multiplication table. So that is 7. So here I will have finally inside 7 to the power 3 under the cubic root. I could found a number when I multiply it by itself 3 times, I will get 343. So this is the prime factorization for this one. For 343, it's 7 times 7 times 7, which is 7 to the power 3. That means the answer is 7. I'm sure you all will do it immediately by calculator. You want to spend all this time that I'm doing this part with you. But I want to show you all possible things. Now the rest I will finish them easy and fast. I know that 16 to the power 1/4, which is, what is the number when I multiply it by itself 4 times? It's 2. 2 times 2, 4 times 2, 8. 8 times 2, 16, and that's what I need. So when I multiply 2 by itself 4 times, I will get 16. That's why I wrote this. Now, what about 125? So 125 is, the cubic root of 125 is equals to 5. So 5, once you multiply it by itself 3 times, you will get this one. Now, what about if you have 4? 4 inside 256. I'm not going to do the same way that I did here. You have to try them. So that is to the power 4. Now that's easy. What is the number once you multiply it by itself? 2 times, it's a 12. So I'm done like that. So this is the idea. Now let me move to the next part. Write each expression in radical form. So the radical form, which is using the root. So 3 over 4. 3 over 4, I can write this as a b to the power 3 and all this to the power 1/4, right? So 1/4, I know what is 1/4. 1/4 is the 4th root. You will put this outside and then you will put what you have, the number inside, b to the power 3. That's basic. Now y to the power 1/4. So I know that immediately that's already ready. This is the 4th root directly. So usually take the denominator of the power, put it the degree of the root. Now this one, 16, because there is no parenthesis, so the 16 outside. Now a to the power 2, and that is the cubic root. This one, that's 1 over 2, which is the square root. The square root, you should not write anything here, but if you write 2, no problem. So this is the square root, but we don't usually write the index here. If we don't write anything, that's mean the square root. So it is 4c. But you know what is 4? You know what is the square root for 4? As I told you, from the properties for square root, if you have multiplication, you can separate them. I mean, you can find 4, you can find 2, you can find c, but c definitely it's a variable. So you can say that's the square root of 4 times 2c. So that I know what is this. That's 2 the square root of c. So you can take this outside. Also, you can say that, I will continue up, there is 2 ways. You can say that the square root 2 to the power 2c. You can say that. So since this is 2 and this 2, you can take this outside and just say to the square root c. Now this one, here you have parentheses. Oh, here I must work. I have lots of things to do. So I have 32b, all this to the power 2, all this to the power the cubic root. Okay, then I need to simplify my work because I have to simplify it. So this 32, what should I do with this 32? It might be multiple of 3, so I can take it outside. But before I do that, let me distribute my power to avoid confusing. So 32 to the power 2, b to the power 2. All this. Any problem until now? Now we have this 32. I'm going to go back and write my factorization. So 32, I will do my factorization here for 32. I'm going to divide this by 2, which is 16. Now by 2 again, which is 8. by 2 again, which is 4, then 2, then 2, then 2. Now how many 2? 1, 2, 3, 4, 5. So that is 2 to the power 2, all this, sorry, 5, all this to the power, it looks 25, I will fix it. So that's the power 5, it's coming from the 32. So all this to the power 2, I should not forget that. B to the power 2. Then all this. Okay, so now it's a power raised to another power, which is given the same thing that in the first slide. So that is 2 to the power 15. B 2. All this with the cubic root symbol. Now I know that I can separate them like this. So let's do that. So what is 2 to the power 15 B 2? You know that this fraction will give me power 1/3, right? But I have 15. So 15 over 3, which is will be equals to what? 15 over 3, which is equals to 5. So I can simplify this one by saying that is okay. That's 2 to the power 5. That's the remaining thing. So, oh, sorry, here 2 times, that's 10. Sorry, that's 10. That's 10. So that's 10. So here I have to do one more step. That's a 3. I'm going to raise this one. Now again, I learned before how to write from this step. So that here I can rewrite this one. It is like the opposite direction of a to the power m plus times a to the power n, which is equals to a m plus n. Now this one I can rewrite it to the power 2 to the power 9 times 2 times b to the power 2. All this to the power 3. Why do I need this 9? Why I wrote this 9? Because I know these are the same base. I add the power. So when I add the power, I will get 10. It's like the opposite direction. I'm the one that I'm trying to separate them. Why I need this? Because I need multiple of 3. And the multiple of 3, so I can write 9 over 3, which is equals to, without root, it will be 2 to the power, it will be to the 3. So that's why. Now I'm going to take this one. That will be 2 directly, 2 to the power 3 outside, because that's not a fraction. Now I will leave the rest inside. 2b to the power 2. So what is this? I already know it. It's 8. The cubic root 2b squared, which is here is also cubic root. So that's for this question. This one is easy. So 2, there is no parentheses. That means the exponent only for a. No problem with that. So that is a 3, all this the 4th root. Now that's for this part. Let me continue and do with you. Now the opposite. Here we have the radical form. We are going to convert this radical form into exponential form. So let's do that. That's immediately will be n to the power 3 over 4. So the exponent, the whole number that I have here, will be in the denominator of the power, definitely, and the radical symbol will be 1/4. Now let's do this one. That's exactly same idea that I did here, but the only difference that instead of having this radical symbol, we will have a fraction. I believe that maybe it make more sense for you. So I need to make factorization for this one. So before I do anything, I will make the factorization for this one, then I will start my work. So 128. Definitely some of you can find it directly by calculator. I'll tell you about that, but not all of them, because some of them not perfect root for the given degree. That's why. And you are looking for a number will be multiple of 3. So that's by 2. So once you divide this by 2, you will have 64. Again, by 2, you will have 32. And then we will repeat the same thing here. We will repeat them here. By 2, we will repeat them 5 times. So from here, 5, that will be, how many times I will repeat the 2? So from here, 5 times 6, 7. So that will be 2 to the power 7, y to the power 2. I'm going to change my radical symbol, which will be all this to the power, how much? The power 1/3. As I learned you can distribute the power. But before I distribute the power, I'll play with this one. How can I play with this one? I'll say this is 2 to the power 6. Can I separate them like this? Times 2, which is overall, will give me that, times y to the power 2. All this to the power 1/3. Can I distribute the powers now? Yes. Once I distribute the power, 6/3. Let me write it step by step for you, because some of you, they might feel, what is she doing? Here's like 1. So that's times 2 to the power 1/3. Y to the power 2/3. So that will be 2 to the power. That will be 2 to the power 2. And you know what is 2 to the power 2? Times 2, 1/3, which is, you cannot simplify it. Y to the power 2/3. Let's continue working on that. So that is 4. You know what is 2 to the power 4? 2, 1/3 times y to the power 2/3. I'm done. I have the exponential form and also in simplest form, let me say. So now allow me to raise this part so I can have enough space. So that is, I'll continue. This one easy, because you already know what is 27, which is 3 to the power 3, m to the power 2, overall for this radical symbol, all of this to the power 1/3. Then that's equals to, once you distribute the power, 3 to the power 3/3, m to the power 2/3. So you know what is this? That's 1. So that's a 3. So organize your work and say that is a 3 to the power times, so to the power 1, m 2 over 3. For this one, that will be 5b. Remember, here is there is parenthesis. That means this 4, it's for both of them, not only for one of them. So that's 4 for both of them. And also, this is the square root, which is over 2. I'm going to simplify it now. So 4 over 2, which is 5 to the power of 5b, all this to the power 2. I can distribute this. That's so easy to calculate. To the power 2, b to the power 2. So that is equals to 25 b to the power 2. I'm done from this one. Same thing with this one. If you notice now, this square root, it's only for 81. The z outside. So keep z outside. And what is the square root for 81? You already know it. You already know it. You can write directly that's 81 to the power 1/2. But you know that 81 is 9 times 9. So you can say immediately that is 9 to the power 9z. Now same thing with this one. This one, where can I solve it? I'm going to solve the last one here. So that is 16x, which is exactly the same idea as this one. All this to the power 2. And then inside this one over 4. You can do your calculation. So that is 16x. All this to the power 1 over 4. Please don't confuse if you have the small number inside, that how you simplify the fractions. But I'm confident you are so excellent students. I'm confident you know what to do with this part. So that's over 2, sorry. So once you simplify, divide by 2 and divide by 2. So once you simplify this fraction, 1 over 2. So you know what is which is the square root 1 over 2 times x to the power 1 over 2. So what is this? What is the number when I multiply it by itself? 2 times I will get 16. What is this number? 4. 4x to the power 1/2. Like that, I finished this part. I think these exercises, enough. Try to review them and do all the exercises that I gave you before, also in the class and in the homework. So here we have write each expression in exponential form. That's exactly the same thing. I think the same thing that I did here, but I repeated them here maybe because I need a space, but I forgot I wrote them 2 times. Now here, we are done like this from lesson 7.5. These are the important thing in lesson 7.5. In lesson 7.6, we have to evaluate. If I'm telling you to evaluate, so if I'm telling you to evaluate this part, evaluate each function over the domain. The idea is really simple, and you need to say the domain is increasing or decreasing. Let's check out. So if you see, all your job, I will substitute this in the x place and see what's up. Let me figure out the domain for the first. Here, -1. I'm going to substitute -1 in question 52. So in question 52, we have y equals to 3 to the power. So once you have negative, you will get a 3 to the power -1, which means that is 1. Once you substitute by 1, you will get 3. Once you substitute by 2, you will get 3 to the power 2, which is 9. Now you will figure out, is this increasing or decreasing? Look at the numbers. The numbers get bigger. That means this function is increasing. This is the idea. Same thing with others. Once you try to substitute, you are going to see if the numbers get bigger, so that means it's increasing. Once the number gets smaller, that means it's decreasing. Same thing with the rest. I'm not just calculating because we will repeat this part. So I know these slides now, it's not given in the sheet. It just, you will find them in my PowerPoint. I found them useful and we discussed about the concept in the class, which means here, how can we identify linear functions and exponential function. So determine whether each table represent a linear or exponential function. So we said that they reminded you here what is the exponential function is. So both exponential function and linear function, the difference between the x's constants, which means by addition or subtraction. While here, the y is the only our focus on y. If this constant, I'm fine. Y here, what is the difference between what is the pattern here? You will notice that here multiply by 2. Again, this will be multiplied by 2. So we have, that means common ratio because it is multiplication, the pattern given by multiplication. Again here by 2. Since I have here multiplication, the pattern is multiplication or multiply by 2 and it's constant in all of them. I mean, I have common ratio. Since I have common ratio, that means this is exponential function. So that is exponential function. While this one, if you try to multiply by a number, like here multiply by 4, what about this one to this one? No, we cannot multiply by 4, so we can get 7. That means that is wrong. I will move to addition or subtraction. If I add here, if I add 3, okay, I will get 4. From this one to this one, I'll plus 3 again. From this one to this one, plus 3 again. From this one to this one, plus 3 again. From this one to this one, plus 3 again. Okay, I have common difference. Since I have common difference, that means this is linear function. So that is linear relationship or linear function. So why they said explain. So step by step, once you read your question, explain for the first one, because I'm not going to write because of the time, because of I cannot write. You will see that this video I'll take more than my time because I want to finish all the question that I want to say, because I have common ratio, because the common ratio is constant. Ratio, you will say ratio is constant. So I answered the first part. In the second part, I should say about it, and they told you to remember and then they explain. So that's the explanation. So that is linear function. So you are going to say exactly the same reason, but you won't say the common ratio. You will say the common difference because there is addition and multiplication. So that's similar if you notice that to the geometric sequence and arithmetic. So the arithmetic is, it is linear relationship, while the geometric is exponential function. So that's the relationship. I would like to connect all your information together. Now here we learned these from the table. How can we identify that from table? Here we will identify from equations. That's corresponding to this form. That means this is the exponential function. That's corresponding to y equal mx plus b. That means this is linear. Also, you can say all the power for all the variables is 1. That means this is a linear. Even if you don't have this form, if you have all the powers 1, that means for the variables, that means this is a linear relationship. We need to graph. So the graphing here, I told you, you must make table. So just make table for your graph. Just write, here is x, choose some value, any value you like. So that is y, I will find the y values, which is equal to the power x. So once you substitute, I told you to use 2 values on the left and 2 values on the right, unless if you have word problem that will stop you to use negative numbers. So once you substitute by negative 2, you will get 1/4, which is equals to 0.25. If you substitute by negative 1, which is 1/2. If you substitute by 1, which is 1. If you substitute by 1, which is 2, then once you substitute by 2 is 4. So what is useful from things that I said in the beginning of in the first part, which is you can, once you graph, you will figure out where is your graph. So when you graph them here, you know that you will know that this should be in the top part. And you will figure out that directly without sketching the point that your graph will be something similar to this one. Something similar to this one. Let's sketch. I'm sorry, my handwriting. I think I have to. Okay, so let me try to graph this. So once I graph, I'll put my here 1, 2, 3, 4, and so on. I mean, each square represents 1. So that is negative 1. That is negative 2. So once I sketch negative 2 and 1/4, so that will be very close from the x-axis. Once I sketch negative 1/2, which will be in the middle of this line. Once I have 0, it will be 1. Once I have 1, here is 1, it will be 2, so here is your point. Once you have 2, it will be 4, and that's the. So once you continue your work, you will find the function look like that. Same thing with this one. You are going to do your table. You are gonna just use the same value. You can use other values, but I mean you have to take 2 values on the left hand and 2 values on the right hand and the 0 with them. So negative 2, but I usually use these because these are easy numbers. So I encourage you to use the same thing. So once you have negative 2, you will substitute here. You have to focus on that. So that will be 3 times 2 to the power negative 2, which will be equals to, you will move this down. So it will be 3/4. So 3/4 is like this. Now, if you have negative 1, it will be 3/2. 3/2. Then you have 0, it's 3. You will substitute here, so that will be 1, so it's a 3. Once you have substitute by 1, 2 times 3, it will be 6. Then finally, it will be, once you have a 2 to the power 2 is 4, so 4 times 3, it's a 12. So you will sketch these. I think I did something similar to this one. Once you sketch these, you will get something similar to this one. Just take them and sketch them, and that's it. Now here we need to solve. Here there is 2 ways. In the class, I explained for you, and again, in your book, the main concept in your book using a graph calculator. But I told you, I don't want you use a graph calculator until now. I just want you to try it by your hand and solve. The main idea from solve, find the x value. I'll show you 2 ways. Just the graphing part, I will keep it for you. I'll just discuss it with you. I told you, divide the equation that you have into 2 parts. which is saying y equal, which is the exponential part, which is 2 to the power x, and the other part y equals to 16, which is very easy to graph. This function, we already graphed it here. Just to graph it in the same coordinates plane. Then this function, that means it's a y, the line that passes through in the y-axis in 16, which is here, you will find it somewhere. I'll count until 16 and make your line. Then the intersecting point, you will find it. But let me tell you, this is not the only way to solve equations like this. I will give you an easier way. See if you like it and if you can use it for Pearson because it's multiple choice. Now, same thing for this one. Take the part, the exponential part, which is 10 times 3 to the power x, y equals 19. There is a nice way here. You can simplify. Before you do that, can I divide both sides by 10? As I said, if you do something here and you do something here, your equation will be still same. So I will have 3 to the power x equals to 9. So that will be, let me erase, here will be easy to graph. It will be easy for you, easier. So that will be 3 to the power x according to that. The other one will be 9. So the other one will be 9. Again, you will graph this and then you will take the line that passes through 9. But this kind of equation, it's very easy to solve. Can I rewrite this one into a number which is base 2? Yes, I know that 2 to the power 4 will give me 16. Any problem with that? I just convert this one into 2 to the power 4. I know that 16 is 2 times 2 times 2 times 2. But miss, my question is, you might ask, there is a question in your mind. Why don't you write it's 4 times 4 and say here, no, I want this one because I want to have the same base as here. So 2 to the power x. Now, my question is, I need this. Here I have the same base here. What is the only value will make these two sides exactly same? X equals 4. Just done. So the intersecting part will be, if you try to find it in here in the graph, you will find it exactly same thing as this one. Same thing with this. I'm going to do exactly same thing that I did before. I will divide by 10 both sides. Once I divide by 10 both sides, I will get a 3 to the power x equals to 9. Can I rewrite this one into a 3 to the power 2? Yes. So 3 to the power x. So that is x equals to 3. Equals to 2. That's the answer. So that's for this part. Finally, which is the last lesson, just determine whether the sequence is geometric sequence. You will figure out if the common ratio constant, you will say it's geometric. If it's not, you will say this is not. So let's see the first one. The first one, from 1 to 4, we can multiply by 4. From 4 to 16, we multiply by 4. You might have started wrongly, I mean by 4 here times 4. You might say, okay, miss, I'll plus 3. If you plus 3 and see you reach to 4, yes. But from 4 to 16, if you plus 3, will you get 16? No. So that's why you move to multiplication. But I started with the multiplication, I found it's correct. So the common ratio is constant. That's geometric. I'm not going to write. I'll say the answer. So that's geometric sequence. Why? The reason, explain, because the common ratio is constant. I'll do one more with you. If you look at this one, if you say, okay, I will start with multiplication. Okay, miss, that's a plus 3, times 3, sorry. But will you move, when you move from 15 to 25, will you multiply by 3 to get 25? No. So that means this is wrong. I'll use the other thing. I'll say, okay, to move from 5 to 15, I can say plus 10. Okay, once I'm moving from 15 to 25, a plus 10 again. Okay, wonderful. From 25 to 40, that's a plus 10 again. Great. So I have here common difference, not common ratio. So that means it's arithmetic. It is not geometric sequence because I have here common difference, not common ratio. And similarly with these two exercises. Find the common ratio. This is the common ratio that I'm finding. Exactly same idea. So here from this one to this one. If I'm telling you find the common ratio for each geometric sequence, that means directly you will start by multiplication or division. Because I'm telling you it's geometric, directly find the common ratio. So just find it here, divide here once you move from 2 to 8, you are multiplying by 4. From 8 to 32 times 4, so that's the common difference. So the common difference R is equals to 4. Same thing with this one, this is division. You will divide by 10. So instead of writing this one divide by 10, you can say times 1 over 10. So 1 over 10 multiply by 1 over 10 to get the others. Now this is important thing. I need to write the explicit and the recursive formula, which was very important thing. But I need to focus on my question. Determine each sequence geometric or not. So I'm not directly going to write my explicit formula and recursive formula unless I check first. So let me check first the first one. The first one from 4 to 16. What is the relation between them? I can say it's times 4. But will I, if I move from this one to this one, will I multiply by 4 again? No, I'm not getting this one. So that's wrong. So that's not geometric, not geometric. Since this is not geometric, I cannot write my explicit formula and the recursive formula according to this lesson. I might say it's arithmetic. I did not check or not, but I don't want you just worrying about arithmetic because arithmetic in the first semester, it was in the first semester. Let's check this one. So here, if we multiply by 4, we will get a 12. If we multiply 12 by 4, we will get 48. If we multiply this one by 4, we will get 192. So 48 times 4. Also, I will get yes. So that's yes. It is geometric. Since it's geometric, I will find my common ratio. So my R is equals to 4. I will write my explicit formula. So your explicit formula is, you should memorize it, AN equals to first term, which is, let me remind you, it is A1, this is the general form, time R to the power n minus 1. So that is, what is A1? A1, it's 3. R, it's 4 times 4 to the power n minus 1. That's my explicit formula. So the recursive formula is, just write A1. What is A1 is, which is equals to 3. What is AN? The nth term, which is the previous term, AN minus 1, times R, times 3. You can change the order for these because the multiplication according to commutative property of multiplication. So that's for this part. Now, I like this question also. This is geometric sequence represented by this function. What is the initial value? This is the initial value. Then, what is the initial value of the sequence? What is the common ratio? The common ratio is 2. So the common ratio is 2. Now the initial value is 3. That's it. Find the first 4 terms. Just change the opposite. I gave you in the class how to convert from the explicit formula into function. Here is the opposite. I'm giving you the function. You need to change this one into explicit formula. To change that, the opposite, AN equals to 3 times 2 to the power n minus 1. I need to find the first 4 terms. The first 4 terms, that means I need A1. A1, which is directly, here when I substitute, it will be 3, which is directly the initial value. A2, which is equals to a2, which is equals to, just multiply it here 2. So 2 minus 1 is to the power 2, to the power 1. So 2 times 3 is 6. a3, multiply, take this one, multiply it by by